Hello everyone, myself Nirupam Chatterjee, your educator for today, representing a video lecture for the students aspiring for NEET 2021. Here we will try to provide you a mock test paper based on the prediction, and also this mock test paper consists of the new question paper, a new pattern suggested by NTA recently. As you know, as declared by NTA, the new question paper of NEET 2021, it comprises two parts. It will have part A, another will be part B. The part A, it will have 35 questions where you have no option. You have to answer all the 35 questions and only single option correct. Whereas part B, where you get some options, part B comprises 15 questions, and out of 15 questions you have to answer only 10 questions. Here also the question leads to definitely the single option correct. Now students, you know, for such competitive exams, whatever may be the talent you have, the practice is very much important. Unless and until you practice, you will not get a proper success in such examinations. And not the practice like you will practice haphazardly, it will not provide you the proper success. You have to practice in such a way that almost simulate the question papers asked in NEET exams. We don't have to go for a very tough questions. We don't have to go for a very loose questions. We have to maintain the standard of recent NEET exams. Now, viewing this matter, here we are representing a mock question paper. And this mock question paper, we have our target, our motto is to establish almost all the question papers, all the questions which are very much important with respect to NEET exam. So go through this question paper, go through this digital solution of this question paper and enjoy, and try to make yourself tuned in such a way so that in the final examination paper you will make it much easier. So let's move with our digital solution and try to make yourself more compatible with respect to the next upcoming exam. So let's see, we are quickly moving to our question paper. So definitely according to NEET exam, first I am trying to establish the question paper which belongs to section A. So the section A, here we have prepared 35 questions. So the first question, think, a reaction is given, the reaction provided ammonia and oxygen that leads to nitric oxide and water. Now it is asked 1 mole of ammonia, it is reacted with 1 mole of oxygen. So how much moles of what will be the correct options? Now, how will be the correct options leading to this 1 mole when 1 mole ammonia and 1 mole oxygen is allowed to react? So think, first you have to choose, you have to think in your syllabus from which part this question is framed. So definitely it is a question based on limiting reagent. So this is the first strike when you observe a question, when you follow up any question, so from which part this question is asked, that should be strike first. So let us try to solve this question. It is given ammonia which remains in gaseous state. The balance coefficients are given. It is reacted with oxygen, giving the product like nitric oxide, 4NO followed by 6H2O. So NO is gaseous and water is remaining in liquid state. So I think the initial amounts of ammonia and oxygen before reaction, it is given in both the cases by 1 mole. So definitely nitric oxide and water, it will be present by 0 mole. Now we have to find out to solve this problem, first we have to find out the limiting reagent. Now what will be the trick to calculate limiting reagent very quickly? So this trick you have to remember. So calculating limiting reagent ammonia, so divide the given stoichiometric, given mole by the stoichiometric mole. So given mole, it is 1 divided by the stoichiometric mole 4. So we have this value 0.25. Whereas oxygen, the given mole, it is also by 1 and it will be definitely 5, that is 0.2. Now when you do it, now try to find out from here, from this concept, which one is smaller. So definitely we find that oxygen is smaller. So definitely this oxygen will be the LR. This oxygen will be the limiting reagent. So to solve this problem, the very important part, you have to find out which is the limiting reagent. So the basic concept, take the given mole and that mole should be divided by that particular stoichiometric ratio, and the stoichiometric ratio which is found to be smaller one, that should be considered as the limiting reagent. So we have this concept, when we find out this limiting reagent, so definitely the limiting reagent amount, it will be 0. So the after reaction, definitely oxygen present, it will be 0. So ammonia present, it will be 1 minus 4 by 5, let it is 1 by 5 mole. So if oxygen is 0, so further chemical calculation should be done on the basis of oxygen. So definitely nitric oxide, it will be 4 by 5 and water produced, it will be definitely 6 by 5 mole. Now let us try to find out what are the correct options. So 1 mole water is produced, no, it is not the correct option. 1 mole nitric oxide will be produced, no, nitric oxide is produced by 4 by 5 mole. All oxygen will be consumed and all the ammonia will be consumed. So definitely we find that since oxygen is the limiting reagent, so all oxygen will be consumed. The correct option, it will be option 3. Now when you solve this question, when you face the questions in question paper, always try to find out the weak points of the question. Now without going through this solve, I can also go for the correct options. It will be much easier for us, since it is given, since nitrogen, ammonia and oxygen are given in 1:1 mole ratio, which is not in their stoichiometric mole ratio. So definitely either ammonia or oxygen, any one of the substance will act as limiting reagent. So here, since both ammonia and oxygen are given as limiting reagent, so either option 3 or 4, it will be correct. Option 1 and 2, it will not be correct. So by viewing, you can immediately just cross the option, you just knock out the options like 1 and 2. So definitely it will be much easier for us in that case to find out which will be the correct option. Okay. Now let move to the next question. How many moles of aluminium it will react with 3 moles of NaNO3 in basic medium? So it is a question related to stoichiometry. Now no reaction is provided. So you have to solve this question by utilizing the concept of equivalence. So let us take aluminium. It is allowed to react with NaNO3. So in presence of basic medium. So we have this idea that when aluminium, it will react with sodium nitrite, it leads to the formation of ammonia, and it will produce, definitely it will produce NaAlO2. The substance produced, it will produce NaAlO2. Okay. So first of all, this information you must have. When aluminium or zinc, they are boiled with alkali, they will produce hydrogen, and that hydrogen, nascent hydrogen, will reduce nitrate or nitrite salt, and in that case it will be converted to ammonia. So to solve this problem, first think what will be the changes in oxidation number for aluminium. It will be 0 to +3. And what will be the change in oxidation number for nitrite? It is +5 to -3. Now to solve this problem easier way, in the classes, most of the cases I say a method which is very tricky. The term we use, the TOPY method. The TOPY method we use, what will be the TOPY related to aluminium? So aluminium, it will go for how many, loss of electrons. How many electrons are lost when aluminium is converted to Al3+? Definitely it will lose 3 electrons. So I would say the TOPY of aluminium, it will be 3. Now how many electrons are gained by NaNO3, that nitrogen? It will be definitely +5 to -3, +8 electron. So what will be the TOPY for NaNO3? It is definitely 8. So simple, we will alter the TOPYs. We will alter the TOPYs. So put 3 here and put 8 here. So definitely the balance form, that will involve 3 aluminium plus, it will be 8 aluminium followed by the TOPY. It will be 8 aluminium followed by 3 NaNO3. That will be the balancing coefficient of this reaction. Now it is asked that 3 moles of nitrate, it will react with how many moles of aluminium. So clearly it is quite obvious to us, definitely 3 moles of NaNO3, it requires 8 moles of ammonia. So by in a very easy way we can find out the correct option. It is option 8. You can go through the concept of equivalence, but it will take time. That is why just find out the TOPYs, the corresponding components. Exchange their TOPYs, you will get the answer. Okay. Now the next question. See, it is said that which of the properties indicated is not correctly indicated, or which is indicated correctly. Which of the following statement is not indicated correctly, does not in agreement with the periodic properties. So it is a question from periodic table. Now the first, it is said that the electron gain enthalpy of halogens. So it is very clear to us that electron gain enthalpy of halogens, it will follow iodine, it will be least, then it will be bromine, and there occurs an exceptional situation, fluorine having less electron affinity value than chlorine. It is a well-known exception in periodic table. So definitely the order, it will be not for chlorine, it will be fluorine has lesser electron affinity value or electron gain enthalpy value than corresponding that of chlorine. So here definitely this property is not indicated correctly. So we have the correct option, it is this. Now we can move to other questions also. The increasing metallic radius. We have the correct idea. If we move down the group, definitely metallic radius increases. So lithium, sodium, potassium, rubidium, they are placed in the down the group, so their metallic radius will increase. The increasing ionic size, the greater the positive charge of a particular atom, the atomic ionic size decreases. So Al3 plus having higher charge, so it will have smaller size, then Mg2 plus, then Na plus, and F minus negative ions, they will have greater size. Now here also increasing ionization enthalpy. Ionization enthalpy, it is also a very important idea where you have to memorize that. Definitely an important conclusion. Though nitrogen is placed before oxygen in the periodic table in a particular period, though it will be the ionization enthalpy, it will be for oxygen, it will be lesser compared to that of nitrogen. It is also an well-known exceptional situations, because nitrogen has half filled configuration whereas oxygen have partially filled configuration. Okay, so the correct option here definitely it is option 1. Let's move to the next question. Again, see students, we have arranged the questions in such a way as compared to the pattern of previous years in NEET exam. So the questions are framed in this way. Actually, you may find questions from periodic table, you may find questions from stoichiometry, you may find questions, again you see the question from chemical bonding. The question, it is asked, which of the following pairs it will have isostructural pairs. What are isostructural? Isostructural means they have the same structure. So how to find out? You have so many options. Either you can find out, you can draw their Lewis dot structure, you can find out their hybridization. So whatever may be the method you can apply, you can find out the isostructural pairs. Definitely they should have the same structure. Isostructural pair means. So if I would go for just simple Lewis dot structure, SO3. So SO3 definitely it will have S double bond O. It will be S double bond O and O2 minus, definitely two oxygen atoms, they will have O2 minus followed by a lone pair on sulfur atom. It will have pyramidal structure. It will have pyramidal structure. Whereas if you write NO3 minus, so that NO3 minus, it will have a planar structure. It will have planar structure. So definitely these two pairs are not isostructural. This is not the correct option. BF3 and NF3, this is also a well-known example. BF3 it will have a planar structure, whereas NF3 it will have a pyramidal structure. BF3 it is planar, whereas NF3 it does not have a planar structure, it is pyramidal. It will have a pyramidal structure. Now question 3, option 3, BRO3 minus. If we write BRO3 minus, so BRO3 minus, bromine having 7 electrons. So I would make a double bond, again double bond. So how many electrons of bromine are utilized? 4. Again a single bond oxygen with negative charge, 5 electrons, and there will be a lone pair. So total 7 electrons of bromine are utilized. So it will have a pyramidal structure. It will also have a pyramidal structure. And in case of XeO3, just follow. XeO3 xenon have 8 electrons in its valence shell. So put double bond oxygen, again double bond oxygen, again double bond oxygen. So how many electrons of xenon is utilized? So definitely 6 electrons. The rest of the electron it will acting as a lone pair. So both will have pyramidal structure. So definitely these two have isostructural pairs. They are isostructural pairs. Now last, if I would explain this SF4 and HCF4. So SF4 definitely it will have a seesaw structure. It will have a seesaw structure. SF4, it is seesaw, original, the shape it is seesaw, and it maybe you can say it is trigonal bipyramid structure. With respect to structure, it will be trigonal bipyramid. One of the vertex you will find a lone pair, so it appears to be a seesaw. Whereas XCF4, so XCF4, it does not have a seesaw structure. XCF4, it is simple, a square planar structure with lone pairs. It is square planar. So definitely we are getting our correct option, BrO3 minus and XCO3, they will have isostructural pairs. So in NEET exam you may expect a question from chemical bond will be like this. So always go for a practice of different structures given in NCERT text. The more you practice, the structures you can remember in more easy way, and it will be much easy for you to answer these questions very easily. Let us move to our next question. So see, it is a question from atomic structure. Definitely will find a question in exam like NEET. A question definitely it will be set from atomic structure. So it is said that the amount of energy required to remove electron from Li2 plus ion. So Li2 plus ion, definitely it is a single electronic species and Bohr's theory is applicable for it. So the ground state, we have to move electron from ground state. Definitely if we move the electron from ground state of Li2 plus and to make it Li3 plus, so in that case the energy required for that purpose, it is called ionization energy. Now it is asked, the ionization, what will be the ratio of ionization energy of Li2 plus and with that of hydrogen atom? So you can solve this question very easily if you have this knowledge that ionization energy is practically equal to the positive of ground state energy. If you understand this, if you have this idea, then you can solve this question within fraction of second. Okay, so I am trying to give a short explanation related to this question. So we have the energy of electron. The energy of electron in Bohr orbit, that can be given by energy, it is minus 13.6 by n square into z square. This is the formula related to energy of a single electronic species according to Bohr's theory. Now for lithium 2 plus. So for lithium 2 plus, you think for lithium 2 plus to bring an ionization energy, you have to move the electron from n is equal to 1 to n is equal to infinite. N is equal to 1 to n is equal to infinite. You have to move this electron. So think, what will be the energy of Li2 plus in ground state? Energy of Li2 plus in ground state, definitely it will be, just put this value, minus 13.6 into 3 square followed by 1 square. Whereas energy of Li2 plus in n is equal to infinite, so if you put n is equal to infinite, that value is 0. So what will be the ionization energy? Ionization energy or energy required to move the electron from ground state to the state of infinite where the energy of the electron becomes 0. So definitely it will have this value. It will be 13.6 into 9. Okay, it will be 13.6 into 9. Okay, minus 0 minus this value, it will be 13.6 into 9. So similarly for H hydrogen atom, what will be this value? Hydrogen atom, what will be this value? You can easily find out. Again, we have to move the electron from ground state to n is equal to infinite. So for hydrogen atom, you can easily say this value ground state, it will be 13.6 minus 13.6 electron volt, and when it is moved to infinite, the energy of hydrogen atom n is equal to infinite, that will become 0. So ionization energy of hydrogen atom, it will be 13.6. Now you may compare what will be the ratio, how many times it will be had. Definitely it will be 9 times. Now think, I have taken time to solve this, but if you have this idea that ionization energy means the positive of ground state energy, if you have this idea, then you can solve it orally. Okay, the ionization energy of Li2 plus, definitely it will be 9 into 13.6. The ground ionization energy of hydrogen, it will be 13.6. You can easily find out the answer. It will be 9 times. Okay. Now see, again a question is asked from Grignard reagent. This is a question from Grignard reagent. It is said that why we are carrying out the Grignard reagent reactions in dry ether medium. If we have water, then what will be the problem? It is a very common question that Grignard reagent, it is RMgX, R minus, it can act as a base also. So it will react with water and it will produce alkane RH. So the correct option, definitely the stronger acid water, it will displace weaker acid RH from its salt. So I can write, it is definitely RMgX. It is R minus, Mg plus. Now this center, it will act as a base. Here it will act as a base. So it will react with water. Now water here, it will act as acid. It is acid. So if they will mix, they will lead to the formation of definitely RH, alkane, and it will produce MgOH. So the correct option, you can easily understood that the water being a stronger acid, it will combine with the conjugate base of RH and leads to the formation of the salt, that is MgOH. Okay, so the correct option, definitely it is option 2. Now let's see the next reaction. When you find out this reaction, this is a question from alkyl halide. When you find NaI in acetone, definitely it is a Conant-Finkelstein reaction, which is undoubtedly SN2 reaction. The reaction mechanism, it will follow SN2. Now it is said that we have a compound which has fluorine as well as bromine for displacement. A compound having both fluorine and chlorine for bromine for displacement. See, it is bromine, it is hydrogen. Now you have added NaI, 1 mole of NaI, that is I minus 1 mole. Now the question, this 1 mole I minus, it will displace whether fluorine or bromine. Now definitely the answer it is bromine because CBr bond is weaker. It is weaker than CF bond. It is weaker than CF bond. So definitely this I minus will attack to this center and it will release Bi minus. So the correct option will get, definitely this part will remain same, there will be no change. It is fluorine, it is H. Now since it is an SN2 attack, so iodine will be attached to here and H will come to this place. So no doubt, see which will be the correct option. So this part will remain unchanged. Here this part is changed. So these are not the correct option. Just strike out these two. So the correct option between 1 and 2. So think here, in both the cases bromine is replaced. But in this case the configuration is retained. But here the configuration is altered. In SN2 we know that there occurs an inversion in configuration. So definitely correct option, it is option 2. Now rate law expression for the reaction, it is given. It is a question from chemical kinetics, class 12 portion. So what will be the unit of rate constant? So it is very simple. Just try to memorize in this way. For zero order reaction, the rate constants, it becomes, it is mole per liter per second. You can memorize the general formula, but think it will be much easier if we memorize this trick. For zero order reaction, it is mole per liter per second. For first order reaction, it will be per second. For second order reaction, it will be the option, it will be liter per mole per second. The situation will be just reverse, and so on and so on. If we move more, so in that case for third order reaction it will be then liter square per mole square per second. For fourth order it will be liter cube per mole cube per second. For 10th order reaction it will be liter to the power 9 mole to the power minus 9 and second inverse. So here it is very simple. The order of this reaction, it is NO to the power 2, O to the power 1. So it is a third order reaction. The order of this reaction is 3. So definitely it will have the rate constant, it will be liter square per mole per second. The correct option, it is option 3. Now it is a simple question asked from coordination and nomenclature related to coordination. Very simple. Cobalt, tetraamine, dichloro, then again chlorine. So in naming the coordination compounds, so first of all we have to name the ligands, then followed by metals, then followed by the anionic part. If the complex part is cationic, then we have to first name the ligands followed by metal with its oxidation state in Roman numeral followed by the name of the anion, and definitely the ligands, they should be arranged in alphabetic order. So here see, we have first find out the oxidation state of cobalt in this complex. Ammonia, definitely it is definitely a neutral ligand. So for chlorine we have total -3 charge, so definitely cobalt here +3. So ammonia, it is named as amine, so it is tetraamine. It will be tetraamine followed by, it will be dichloro, or you may write chlorido. Either chloro you may write or chlorido, dichloro, followed by cobalt 3 chloride. Cobalt 3 chloride. It is cobalt 3 chloride. Okay, so definitely you can easily find out the correct option. It is option 1. Now see, again it is a question from solution from class 12 part. Here the question, it is given, arrange these compounds in order of boiling points. Now boiling point, it depends on the vapor pressure. Vapor pressure, it is a relative lowering of vapor pressure, and boiling points, all these two are colligative properties. It depends on the number of ions present in the solution. So see, here we have NaCl, MgCl2, urea and NaCl. So urea, it is a non-electrolyte, and all these three are electrolytes, so they will produce greater number of ions. Since the alpha is not defined here, so we will take the electrolyte, means it will undergo complete dissociation. So think here the concentration, the lowering of vapor pressure, relative lowering of vapor pressure, it will be directly proportional to number of ions as well as number of as well as the concentration of the ions. So here you find that definitely the concentration of 10 to the power minus 2 molar urea and 10 to the power minus 4 molar NaCl, the concentrations are same, but NaCl, it will dissociate to produce 2 ions, one Na plus and Cl minus. So number of ions in these two cases, here it will be higher compared to that of this. So lowering of vapor pressure, if we say lowering of vapor pressure, or we say relative lowering of vapor pressure, RLVP, that value, it will be directly proportional to the I, Van 't Hoff factor, and also it will be the concentration, I into C, concentration. Okay, so you see here the concentration, it is lower minimum for these two cases. So here lowering of vapor pressure, it will be minimum for these two, and for minimum value it will be for 10 to the power minus 4 molar urea, because it is a non-electrolyte, it will produce only one ion. And this RLVP, it will be also inversely proportional to boiling point. So definitely where the vapor pressure is lowered much, so in that case you have to give more heat to attain the atmospheric pressure. So in that case the boiling point will be higher. So in these two cases, the lowering of vapor pressure is very small compared to that of these two cases. So definitely they have a boiling point, they have relatively lower boiling point. So if we find out this result, so definitely here we find the maximum lowering of vapor pressure. Lowering of vapor pressure, it will be maximum for this. So it will have a boiling point maximum. It will have maximum boiling point, whereas here it will have maximum boiling point, maximum BP, whereas this will have minimum lowering of boiling point, lowering of vapor pressure. So it will have also minimum boiling point. So if you arrange this result, definitely the 3, it will have minimum boiling point, then definitely it will be 4, because the I Van 't Hoff factor into C in these both these two cases are same, I value, it will be higher. So it will have much lowering of vapor pressure. So we need more heating to attain the boiling point. So definitely then it will be 4, and then it will be definitely 2, then it will be 1. So we have the correct option, it is option 2. Let us move to next question. So it is a question from P block. It is a just information basis question. When PCl5, it is reacted with H2SO4. So H2SO4, think H2SO4, it will have the structure like this, OH, and it is also OH. Now when it is, and we have this idea, this PCl5, it is a chlorinating agent. It is a chlorinating. It is a chlorinating agent. As it is a chlorinating agent, it works. It just displaces the OH groups. If it will displace this OH group, it leads to the formation of sulfuryl chloride. It is said to be sulfuryl chloride, and definitely leading to the formation of POCl3 and HCl. Now the question, think, one is a derivative, that is shows that H2SO4, it is a derivative of SO2. It does not deal with the derivative. It is a dibasic acid. It has great affinity to water. It is not also correct. It has 2 hydroxyl group. As PCl5 displaces 2 OH, so definitely it has 2 hydroxyl groups in its structure. This reaction suggests it has 2 hydroxyl groups in H2SO4 structure. Let us move to next question. The oxyacids in sulfur, the oxyacids of sulfur which will contain this given SSS, this type of bond. So if you memorize that thionic acid form, they have the SS bonds. If you memorize it, then you can answer this question just viewing the options. Otherwise, you have to draw the structure. Okay. So in H2S2O4, let us draw H2S2O4. So H2S2O4, definitely it is S double bond O followed by OH. Again it is S double bond O followed by OH, and it will have a lone pair here. So it will have an SS bond. H2S2O7, H2S2O7, it will be like this. No doubt it is O, S double bond O, it is OH. So H2S2O7. I mentioned 2 or 3 times that the structures given in NCERT text, both 11 and 12, those are very important. So you definitely have to practice those structures. So all the questions, they are related to those structures. So H2S2O7, so it has no SS bond. If we write H2S2O6, so it is also H2S2O6. It will be like this. Again H2S2O6, so it will have also SS bond. And lastly H2SO3, it is S double bond S followed by OH, it is double bond O, it is OH. So think, now you can easily answer the question. So these two, this one and these 3, they have SS bond like given in the problem. So we have the correct option. This is 1 and 3. Option 1 is the correct option. Now again a question from ionic equilibrium, solubility product. You can find so many times the questions are asked from solubility product. Simple, a salt is given, what will be the solubility product? You can find, if you follow the previous year question, you will find this type of question so many times. So here we have framed a question which is little tricky. The situation is same. I have selected a question which is little tricky. Okay, so here Li3Na3 followed by AlF6, sorry, that is AlF6 followed by its whole 2. So if it will dissociate, if it dissociates, so it dissociates to produce, it will produce definitely 3Li plus, it will produce 3Na plus, it will produce 2AlF6 3 minus. So if you take it, the solubility, it is S moles per liter. So Li3 plus, it will be 3S, it will be 3S, and it will be 2s moles per liter. So KSP value, KSP simple, it will be 3s whole cube, it will be again 3s whole cube, it is 2s whole square. If you solve it, you will find this result 2916 s to the power 8. You can find that this value, it will take time to calculate. That is why the question is given in such a way. You can find that you just find out the order of s, 3, 3 and 2, it will be s8. So if you find this value, you can easily, the correct option, it will be question 4. Now next, move to this question. It is a question from carbonyls, class 12. It is a question from well-known reaction in organic chemistry, that is aldol reaction. So aldol reaction, you may proceed through its mechanism, but in the examination hall it is not required. You can apply an easy trick that aldol reaction, it is involved between alpha carbon. So alpha carbon of one carbonyl, write one of the carbonyl and write another carbonyl with its alpha carbon, which is directly facing the double bond O of another carbon. Just remove water. Just remove water from here and remove water from here. Don't go for any mechanism. Remove water, you will get the answer directly. See, it will be the answer. It will be the answer, double bond. Use this trick, you can easily find out any answer. Okay, so see what will be the correct option. Definitely it is option 2. Always solve the problems related to aldol condensation in this way. Carbonyl and another compound with its alpha carbon, just write them side by side and remove water. You will get the product easily. Standard electrode potential, question from electrochemistry, again class 12 question. So it is simple, we have to apply Nernst equation. It is a very simple question. We have to apply Nernst equation. Nernst equation, the reaction corresponding to copper, it is copper 2 plus 2E giving metallic copper. And we have to find out the electrode potential at concentration of Cu2 plus 0.0. So just write down the reaction. It is E Cu2 plus U, E degree Cu2 plus U, followed by 0.0591 by 2. How many electrons involved? It is 2. Followed by, it will be log of concentration metallic copper by, it will be Cu2 plus. It will be the formula. So apply these values. Cu2 plus U, it will have 0.34 and it will be 0.0591 by 2. It will have the concentration given 1 by 10 to the power minus 2. So it is 0.34. It will be definitely minus, it will be 0.0591. Take a negative, subtract 0.034, you will get the answer close to. If you remove 0.0591 from 0.34, the close answer definitely it will be 0.281. Okay. So next, move to the next question. We have, so it is again a question set from class 12 portion. The first chapter, it is solid state. Now see, it is said that a mineral, it will have cubic close packed structure. So cubic close packed structure means CCP arrangement. Cubic close packed structure, this is the important term, cubic close packed structure. So oxygen atoms are in CCP. Oxygen atoms are in CCP. That means how many oxygen atoms are present? Oxygen atoms are present at the corners. Oxygen atoms are present at the face center. So oxygen atom, it will be, for corner atom it will have contribution 8 into 1 by 8, and for face center atom it will have a contribution half. So we may write it will be 6 face center atom having contribution half. So in CCP 4 oxygen atoms are present. So definitely in that mineral that is made up of a cubic close packed structure where oxygen atoms are at the corners and oxygen atoms are also lying at the faces. So in the unit cell that contains 4 oxygen atoms. Now what it is said, that m fraction of octahedral void, it is occupied by aluminium ion, and definitely n fraction of tetrahedral void is occupied by magnesium ions. Now if we have 4 atoms, then number of octahedral voids, it will be definitely 4. Since we have this idea, for n number of atoms we have 4n number of octahedral voids, same n number of octahedral voids and 2n number of tetrahedral voids. So number of octahedral voids 4 and number of tetrahedral voids, it is 8. Now aluminium 3 plus ion, number of Al3 plus ion present, definitely. So m fraction of total octahedral void is occupied. Since m fraction of total octahedral void is occupied, so number of Al3 plus ion, it will be 4m, whereas number of Mg2 plus ion, so it is also said that n fraction of total tetrahedral void is occupied, so it will be 8n. So the charge carried by Al3 plus ion and Mg2 plus ion and the total O2 minus ion, definitely it will be the charge of, definitely charge of Al3 plus, it will be 4m into 3, that is 12. Charge of Mg2 plus, it will be definitely 8n into 2, that is 16n. So the total charge, it will be 12m followed by 16n and minus 4 oxygen atoms, it is minus 8. The total mineral, definitely it will have, it will be neutral, chargeless. So we have the final result here. It is definitely 3m plus 4n, that is equals to 2. Now we have to follow this equation. Now just put the values of the 4 options, we will get which one is correct. Definitely it is correct for option 1. If you put m is equal to half, it is 3 by 2. If you put n is equal to 8, so in the 1 by 8 it will give total value of 2. Okay, so in this problem you have to memorize that in CCP arrangement, definitely atoms are located at the corners as well as atoms are located at the face centers. And for total number of atoms, we have, if we have n number of atoms, then the tetrahedral voids 2n and octahedral void n, and in this way you have to organize such problems. Next problem, it is from organic chemistry, a direct question from phenol. Now in the previous exams like NEET, you will find 2 or 3 roadmaps problem like this. So here it is given a phenol, a compound, it is subjected to a sequence of reactions and we have to find out what will be the final product of this reaction. So let us write the first compound, it is phenol. Phenol benzene ring having an OH. It is phenol. It is reacted with first NaOH. If you react phenol with NaOH, so definitely first step an acid-base reaction will operate and it leads to the formation of sodium phenolate. And then that sodium phenolate, it is reacted with carbon dioxide at elevated temperature like 140 degrees centigrade. So it is nothing but a reaction which is called Kolbe-Smith reaction. It is Kolbe-Smith reaction. Now in Kolbe-Smith reaction, the final product we always get, it is a salt of orthohydroxybenzoic acid. It is orthohydroxy, salt of orthohydroxybenzoic acid. It is definitely, according to problem, it is compound A. Now this compound A is being acidified then. So the salt will be neutralized and it leads to the formation of salicylic acid, orthohydroxybenzoic acid, which is said to be salicylic acid. It is definitely compound B according to our problem. Now the next step, it is reacted with or heated with Al2O3 in presence of acetic acid. Now see, what will be the reaction? In NEET exam, it is a trend. If you go through the previous year questions, you will find this type of variations. In none of the book you will find that such a reagent that will react with the salicylic acid. But here you have to just go for an intelligent guess. It will have an acetic acid and it will have a phenolic OH. So an acid and phenol in presence of Al2O3 is a dehydrating agent. It is simply nothing but a esterification reaction. So an esterification reaction, it leads to the formation of acetyl salicylic acid. And this acetyl salicylic acid, it is known as definitely aspirin. Our final product, it is aspirin. So these variations definitely you can find in the upcoming exams, because if you go through the previous year trend, you will find most of the in such roadmaps problem, the most common reagents are given, but in one step some unknown reagent is given. So you have to think how this unknown reagent react with our known compound. Okay, let's move to next problem. Again an ether. This ether compound, it is reacted with HI. So ether is given like it is phenyl benzyl ether. If we name this compound, it will be phenyl benzyl ether. Now cleavage of ether linkage by using hydroiodic acid, which is a very important problem in competitive exams. So definitely, what is the step? Definitely that phenyl ether oxygen, it will be protonated by the acid or protonated by H plus, which is released from HI. And this protonated HI, this oxygen lone pair, it will capture this H plus, releasing I. So this protonated ether group, then it will go for a cleavage. Now the question, the cleavage will take place in which pathway? The question varieties may be different in different cases. Now this breakage will take place from which direction? Whether this bond will break or this bond will break. This is the question when this type of questions are framed. So first we have to think what will be the mechanism in which it will break. So if these two parts, they are either 1 degree both, or maybe 2 degree both, or maybe 1 degree or 2 degree, the reaction will follow definitely SN2 pathway. If one of the part it will be 3 degree or it can produce a very stable carbocation, then the reaction will proceed via SN1 mechanism. So here we are getting such a situation where a benzyl carbocation may involve. Since it is a very stable resonance stabilized carbocation, so the reaction will go through definitely a SN1 pathway. It will break to produce SN1 pathway leading to the formation of phenol first, and it will produce benzyl carbocation. And once this benzyl carbocation is produced, that benzyl carbocation in the next step it will undergo nucleophilic addition. So I minus, it will react with I minus, producing benzyl iodide as the product. Okay, so definitely our product, one of the product, it will be phenol. Definitely we have an option phenol here, it is 4 phenol, and we have benzyl iodide, it is benzyl iodide. So the correct option definitely 1 with 4, it is the correct option. So definitely you have to study this part, that is decomposition of ethyl linkage by HI. It is a very important part with respect to NEET exam. Always think if the both parts are 1 degree, both 2 degree, both 1 degree or 2 degree, reaction will follow SN2 pathway. If either of the part is 3 degree or it may produce a very stable carbocation, it will proceed via carbocation, that is SN1 mechanism. So you have to cleave in that with this concept and you will get the 2 dissociative results. Okay. Next, move to the question 19. Crystal field stabilization energy for high spin D4 octahedral complex. It is relatively easy question from coordination chemistry. D4 system, D4 system, it may be chromium 2, maybe. So D4 system, it has definitely 4 unpaired electrons. D4 system in presence of crystal field, it will split to produce a EG set, it is EG set, and it will produce a T2G set, and this, the difference with energy between T2G and EG, that is called delta octahedral, or it may be 10 dQ. Since it is a high spin complex, it is given that it is high spin complex, so just put the values as normal, 1 electron, 2 electron, 3 followed by 1. So we have this idea that each T2G electron, it is stabilized by -4 dQ, whereas each EG electron is destabilized by +6 dQ. So I can find out crystal field stabilization energy in very simple way. For 3 T2G electron, it will have stabilization definitely -12 dQ, and for 1 EG electron, it will have destabilization +6 dQ. So the final result definitely it is -6 dQ. Since the result is given in terms of octahedral, so 10 dQ, so we can convert it, it will be 0.6 delta octahedral. Okay, so definitely the option, it will be 1. Next, again, I have told you so many times, the questions related to structure and bonding, you have to go through all the structures given in NCERT text. The structures, whatever given in NCERT text, you have to deal with the structures, because the questions, when the questions are from bonding, they are also related to structure. When the questions are P block, they also belongs to the structure. So similarly, you can find out a question from group 18, XCO3, XCO4 and XCF6, the molecules having same number of lone pair of electrons? Very simple question. So if you know the structure properly, what will be the structure of these three compounds, then you can easily find out the answer. XeO3, it will have a lone pair with definitely 3 oxygen with double bond. So it will have one lone pair. If we write XeO4, it does not have any lone pair of electrons. All 8 oxygen atoms, all 8 electrons of xenon, they are bonded with oxygen in this way. And XeF6, you know, XeF6, it will have an exceptional structure like this. XeF6, so definitely the fluorine atoms, it will 4 fluorine atoms are lying on a square plane, 2 fluorine atoms and above the plane and below the plane. So how many electrons we have used for xenon? Xenon having total 8 valence electrons. Here we have used definitely 6 electrons, and the rest of the 2 electrons that will act as a lone pair. Okay, so you can easily find out XeO3, it will have one lone pair, XeF6, it will have also one lone pair. So the same number of lone pairs present, it will be definitely XeO3 and XeF6. XeO4 does not have any lone pair. So the correct option, it will be option 2. Next again, a question from IUPAC naming. In previous year, if you study, you will find a question related to IUPAC nomenclature. So simple, it is asked, it may be asked the correct IUPAC nomenclature regarding this, but incorrect IUPAC nomenclature regarding this type of questions are framed. So it is given which is not correct in according to IUPAC system. If you go through the first structure, in IUPAC system, definitely double bonds and triple bonds, they have higher priority compared to that of any substituent like chlorobromo or something others. So here in this compound, CH2 CH single bond followed by Br. So here the precedence, priority, it should be given to double bond. So double bond should get the list number. The numbering should be done in this way. So it will be 3-bromo followed by 3-bromo followed by prop1-ene or propene. Okay, 3-bromo followed by propene. So in this case, definitely the numbering, it is given from this side. So it is an incorrect numbering. So definitely this compound, the naming, IUPAC naming is not in accordance with this number naming given. Okay, so it is our correct option. It is not written in according to IUPAC nomenclature. Let's move to again. It is a question from stereoisomerism. Now the cis-trans isomerism and its extended form, it is EZ nomenclature. When such a structure is given, you just draw the structure and think the groups are located in which way. Here if you put the hydrogens, then you can easily understood what will be the location of hydrogen in space. So definitely these two hydrogen atoms, they are anti to each other. So for anti, we write it is E. Again, if you write hydrogen in these two cases, here hydrogen and also hydrogen, they are also anti to each other. So it is again E. So no doubt this compound will be, we just follow up, all they have the same naming, 2,4-hexadiene, 2,4-hexadiene, this part is same. So you have to just select the stereochemistry. So stereochemistry, it will be 2E followed by 4E. It is the correct option. Okay. So next, again, here it is given a question related to aromatic character, anti-aromatic character, non-aromatic character. This part is also very important. And here it is a question selected which is very important. Which of the following compound is not aromatic? So definitely if you write down this structure, it is cyclopropynyl cation. So cyclopropynyl cation, definitely it will have a delocalization of 2 pi electrons in a cyclic loop. Delocalization of pi electrons in a cyclic loop. So definitely it is planar, it is cyclic, and it will have 2 pi electron delocalization, or we may say 4n plus 2 pi electron delocalization. 4n plus 2 pi electron delocalization, where n is equal to, if you put n is equal to 0, definitely 2 pi electron. So it is aromatic. It is definitely aromatic. Here also you can delocalize the electron. Here we find 6 pi electron delocalization. So definitely it is also aromatic. Here also, if this nitrogen lone pair involves in resonance, here also it will make this cyclopentadienyl ring aromatic. So it is also an aromatic compound. Now if you study this compound, here you can find the delocalization will take place. If the delocalization even take place, then it will have how many? It will have 8 electron delocalization, which does not matches with definitely 4n plus 2. Even this is a compound which you have to memorize. This is actually cyclooctatetraene, this compound, and this will not exist in planar form. This will exist in a structure like tub shape. It will have an existence in tub shaped structure, where double bonds are present here, here and here. If you make it planar, if you just write down if the structure given, if you consider the structure given in planar form, it becomes anti-aromatic if the delocalization will occur. But to avoid this delocalization, to avoid anti-aromatic character, it will exist in tub shaped structure, and in that case it is non-aromatic. This compound is very common. It is called cyclooctatetraene. In simplified form we write it as COT. Very important informations about this compound. You have to memorize that cyclooctatetraene, it is not planar, it does not exist in planar form, it is actually exist in tub shaped structure, it is not anti-aromatic, it is not aromatic, moreover it is a non-aromatic compound. Next, move to the question. It is again from solid state. It is a question asked with respect to the defects existing in solids. It is given in the crystalline solid. The defects we find Frenkel defect and Schottky defect. Now in Frenkel defect, actually the cations which are in smaller in size, they displaces from their original lattice site and moves to the interstitial space, and such a defect it is called a definitely dislocation defect. Now it is given one of the option, Frenkel defect is a dislocation defect. So definitely it is a correct statement. Frenkel defect, it is a dislocation defect. Now if you study the other options, Frenkel defect decreases the density of the crystalline solid. So in Frenkel defect, none of the atom actually removed from the crystal system, so density remains unaltered in Frenkel defect, but it is given density decreases in Frenkel defect. It is not a correct statement. Frenkel defect is found in halides of alkaline earth metals. No, Frenkel defect, it is observed for the combination of two atoms which have much difference in size. As for example, Ag plus, which is much bigger in size, maybe with respect to some other Br minus, Cl minus, etc. When the difference between the ions, cations or anions are very large, in that case Frenkel defect we observe, but it is not possible for the alkaline earth metals, so it is not also a correct option. Schottky defect have no effect in density, it is wrong. In case of Schottky defect, the pair of ions are removed from the crystal system, that is why density decreases. Okay, so it is not also a correct statement. Our best option in this case, it will be Frenkel defect, it is a dislocation defect. Now see a question related to chemical bonding. We have tried to all the chapters, include all the chapters in this mock test paper. Again a question directly, it is from chemical equilibrium. So the value equilibrium reaction is given, the value equilibrium concentration of A2, B2 and AB are given. If the reaction takes place in a sealed tube like this temperature, what will be the value of Kc? Simple, you just frame the expression of Kc. The expression of Kc, definitely it will be concentration of AB square divided by concentration of A2 and concentration of B2. Just put these values, you can get this result. Definitely AB, the concentration given 2.8 into 10 to the power minus 3 moles per liter, followed by it is A2 3 into 10 raised to minus 3, and again it is 4.2 into 10 raised to minus 3. So definitely 10 to the power minus 6 it will be omitted, and we have this result 2.8 into 2.8 divided by 3 into 4.8. 4. I think it is 4.2 given. 4.2. Remove the decimals. It is 2. It is 3. The result it will be 5.6 by 9. So definitely the result close to 0.6. So we have only one option, 0.6. Definitely it is 0.62. Simple. The value, just know how to write equilibrium constants and the concentrations at equilibrium, put those values, you will get the answers. Now again question from alkyl halide, class 12, organic first chapter. It is said aryl halides are less reactive towards nucleophilic substitution. It is a very common fact. Alkyl halide, the halogen, it is attached to a carbon, whereas in aryl halides, the halogen atom, it is attached to a benzene ring. When this halogen atom is attached to a benzene ring, definitely this lone pair of halogen, it can involve in resonance, and due to this resonance, definitely CX bond gets more double bond character and it becomes more tough to cleave this bond. So definitely these aryl halides will not participate in nucleophilic substitution reaction. Okay, so it is said why it will not occur. This is due to less stable carbonium ion formation in aryl halides. It is not a very good option. Resonance stabilization in aryl halides. Definitely in aryl halides we find the halogen lone pair is more engaged in resonance with the phenyl ring. So definitely I would go for this correct option. Presence of double bond in alkyl halide. So it is not double bond is present in alkyl halide. Inductive effect of aryl halides, they are not the correct option. The best option in this case, it will be resonance stabilization or the resonance process between halogen lone pair with that of phenyl ring or aromatic ring. This is the most suitable answer. Now 1-propanol, 2-propanol can be best distinguished. If you study the questions of previous year of NEET, then definitely you will find some questions which are asked on the basis of distinction between the functional groups or distinction between the organic compounds. Definitely a question related to that fact is given. So here also we have established a question, 1 propanol and 2 propanol can be best distinguished by. So 1 propanol, what we can write, it is, let 1 propanol, definitely it is a 1 degree alcohol. 1 propanol, it is 1 degree alcohol. And 2 propanol, it is a 2 degree alcohol. It is a 2 degree alcohol. These two compounds are to be distinguished, and for the distinction some options are given. Now oxidation with alkaline KMnO4. Now both the cases, they are oxidized by alkaline KMnO4 followed by reaction with Fehling solution. So if they are oxidized by, if 1 propanol is oxidized by it is oxidized by KMnO4, alkaline KMnO4. So 1 degree alcohol, it is oxidized by alkaline KMnO4, which is a strong oxidizing agent. Definitely it will oxidize this 1 propanol to carboxylic acid, and it will be oxidized to alkaline KMnO4, it will be oxidized to ketone. Now Fehling solution, it does not react with carboxylic acid, it does not react with ketone at all. So it is not possible to distinguish them by using Fehling solution. Fehling solution is a very weak oxidizing agent. So there is no question to oxidize the ketone. So in both the cases we cannot apply this method to differentiate between differentiate them by using Fehling solution. So this is not the correct option. Now in both the cases they are oxidized by acidic dichromate. So if you use acidic dichromate to oxidize, so in this case if you use acidic dichromate solution, K2Cr2O7, it may be K2Cr2O7 dichromate in presence of acidic medium. In both the cases the result will remain the same. So this cannot also be used to differentiate them. Now if we just deal both these two compounds, if we oxidize both these two compounds by using dehydration of copper. Now if both these compounds are oxidized by using dehydration, so dehydration copper at almost 300 degrees centigrade. If it is dehydrated using copper at 300 degrees centigrade, it is called dehydrogenation. Dehydrogenation means removal of hydrogen, nothing. Dehydrogenation. So it leads to the formation of aldehyde. And here by the same reaction it leads to the formation of ketone. Now aldehyde and ketones, they can be distinguished by Fehling solution. Aldehydes, if it is allowed to react with Fehling solution, it will give a red precipitate of cuprous oxide. Definitely ketones, they will not respond to this test. Okay, so the best option in this case, both 1 propanol and 2 propanol, they should be oxidized by using a dehydrogenation technique, or both the alcohols, they should be passed through heated copper at 300 degrees centigrade. Dehydrogenation will take place, leading to the formation of aldehyde and ketone, and aldehyde and ketone, they can be distinguished by using a Fehling solution. Okay, and last option, if you study oxidation with concentrated sulfuric acid with Fehling solution. So sulfuric acid, it will go for a dehydration process. In both the cases it leads to the formation of alkene, propene. So alkenes, they do not react with Fehling solution at all. So we have the correct option it is definitely option 3. Arrange the following compounds in order of decreasing acidity. So acidity, it will be decided by, think more, when we decide the acidity of phenols, it is decided by electron withdrawing effect. More the electron withdrawing groups attached to phenol system, acidity increases. Simple. In the first case, if we write this nitro group attached to phenol, so nitro group attached to phenol, definitely nitro group, it will have both minus I and minus R effect. It will have minus I and minus R effect, which will increase the acidity of phenol to maximum extent. Next, the compound, it is minus I group, it is halogen. So if halogen is attached to it, here the factor operating, definitely it is minus I effect and plus R effect of halogen. But in case of halogen in aromatic system, so minus I effect is dominating than plus R. Next, it is methyl group. Now it will lower the acidity of phenolic system. Methyl group, it will supply, it is an electron donating group. It will supply electron density by plus I effect. It will supply electron density plus hyperconjugation effect. And the last one, where the acidity of phenol will be decreased to maximum extent, the group which is aniside OCH3, it will have a plus R effect and as well as minus I effect. Definitely minus I effect is unimpressive in this case. The plus R effect is more dominating. So due to plus R effect, it will decrease the acidity to maximum extent. So let's see what will be the correct option. So acidity, definitely compound 3, it is maximum, then compound 1, 3 maximum, then compound 1, and last it will be 4. So we have the correct option, that is 3. So students, always you study these concepts in GOC. These type of questions are generally framed in NEET exam. Always comparison of acidity and basicity, it is always an important question with respect to NEET exam. Let's move to again a question which is asked from coordination chemistry. It is K3FeCN whole 6. Quite easy question. K3FeCNC FeF6. So K3FeF6, we have to find out the magnetic moment. Simple. So find out the oxidation state. Here iron is in +3 oxidation state. So iron +3 means it is definitely 3d5. Iron 26, atomic number 26, configuration 4s2 3d6. If you remove 3 electrons, it becomes 3d5, and 3d5 means 5 unpaired electrons. 5 unpaired electrons. And 5 unpaired electrons, for 5 unpaired electrons, the magnetic moment, it is calculated by, you should have this formula, it is n into n plus 2 Bohr magneton. If you put the value n is equal to 5, it will be under root 35, and under root 35 means 5.91 Bohr magneton. So clearly we have this correct option, it is 1. Okay. Again, it should be NiCN whole 4. NiCN whole 4 2 minus. A series of compounds, series of 3 compounds are given. Now we have to compare their structures with their magnetic moments. In coordination, if you go through the questions in exam related to coordination chemistry, the structure with definitely the magnetic moment on unpaired electrons, they are the most asked question related to coordination chemistry. So simple, you NiCN whole 4, the very common question, NiCN whole 4, it is 2 minus. Definitely it will have square planar structure. Here nickel, definitely it is DsP2 hybridized, and once it is DsP2 hybridized, it has no unpaired electron, so its magnetic moment it is 0. Next, MnBr4, MnBr4 2 minus, whereas definitely manganese 2 plus, it is manganese 2, it is sp3 hybridized, and sp3 hybridized, so Mn2 plus, it will have 3d5 configuration, it will have 5 unpaired electrons, and definitely for a 5 unpaired electrons we have a magnetic moment, it is 5.91 Bohr magneton. And last one, it is given, it is COF6 cobalt, COF6 3 minus, COF6 3 minus, definitely cobalt 3, here it is outer orbital octahedral complex, so hybridization it is sp3d2 and sp3d2 for cobalt 3, definitely it is 3d5 3d6 system, and for 3d6 system 4 unpaired electrons, therefore magnetic moment it is 4.19 Bohr magneton. So think what will be the correct option. Square planar complex, first one is square planar, it's okay. Just think about this question. So here first, the NiCN4, it is tetrahedral, these two tetrahedral options, you can strike out these options. NiCN4, it is not at all tetrahedral, it is square planar, so definitely our correct option between it will be 3 and 4. Next, go to the next, MnBr4 tetrahedral in both these cases, then it is octahedral in both these cases, so you have to check the hybridization. First case it is DsP2, sp3, sp3d2, it is sp3d2, but here given inner orbital octahedral, so it is not the correct option. The correct option it will be this, the magnetic moment 0. First case it is magnetic moment 0, second case 5.91, third case it is 4.9 approximately. It should be 4.9. Okay. Let's check the next question. It is a question from class 11, S block. Now it is given a metal, it may be the given metal, definitely group 2 metals, alkaline earth metals. It readily forms water soluble metal sulfates. If you write the group 2 metals, they are beryllium, magnesium, it may be calcium followed by strontium. If we study the solubility of sulfates, so solubility of sulfates decreases. Solubility of sulfates decreases down the group. So definitely the sulfate of barium, it is mostly soluble. So the first result it matches with the our expectation that water soluble metal sulfate MSO4, if it is beryllium sulfate, it is soluble in water. Next, it will produce water insoluble hydroxides. Now solubility of hydroxide, it increases down the group. Solubility of metal hydroxide, it is increases down the group. So definitely beryllium hydroxide, it will be least soluble, whereas strontium hydroxide or maybe barium hydroxide, it will be most soluble. Now it is said that the oxide MO, it becomes inert on heating. Now beryllium oxide, if it is heated, it will go for polymerization, and as it will go for polymerization, definitely it becomes more and more inert. Now the hydroxide, it is given the hydroxide of that particular metal, if we take it as beryllium hydroxide, it dissolves in NaOH because it reacts with NaOH to produce water soluble Na2BeO2. Na2BeO2 plus followed by water. Just try to balance it. It will be definitely 2H2O. Remaining oxygen you can find it is 2. Okay, it will be sodium metaberyliate. The compound, it is water soluble. So we have tried select a question here where you can get almost most of the information related to S block. We have framed such a question which will give you the information like how the solubility of group 2 metals varies. So solubility of group 2 metals down the group it increases. How the solubility of hydroxide varies, so down the group it increases. It also gives us some special information. If beryllium oxide is heated, it goes for polymerization and definitely it becomes very inert in structure. You can also find out the beryllium hydroxide, it is also amphoteric in nature. It reacts with both acid and alkali. You find the reaction, it dissolves in alkali, that means it reacts with alkali. So we have tried to frame the question where we can give maximum number of informations to you. So let's move to the next question, the characteristics features of seesaw geometry. So it is very simple. Seesaw geometry actually it originates from a basic geometry which is called trigonal bipyramid. If atoms are located in this way, it is called a TBP geometry. And in TBP geometry, if one of the vertices is occupied by a lone pair, it definitely goes to the equatorial side to avoid repulsion. So definitely a seesaw geometry means the axial bonds will remain unaltered. One of the equatorial bond, it will contains a lone pair. Such a geometry we say it is seesaw. So what is given? One of the equatorial position is occupied by lone pair. So it is the correct option. Now it is a question from electrochemistry and definitely the question is selected from conductance. Simple, the conductivity. We have this idea conductivity kappa. It is equal to resistance 1 by resistance into cell constant maybe L by A. This is a well-known formula according to conductivity of a solution. Just simple, put the values, you will get the correct answer. Resistance, it is given 1 by 55 and definitely cell constant, it is 0.616. So the correct answer you can find out if you put the decimal, if you shift the decimal to place, it will be 10 to the power minus 2. So think, you may find that how to calculate it. So simple, compare the result. The result will be 10 to the power minus 2. Here we have two options, 10 to the power minus 2. Now if you find out this result, it will be 155 ones are 55, then decimal, then it will be definitely the result becomes 6, that is 66. Again the next value it will be 1, the next value it will not be 2, it will be 1. So definitely our correct option is 2. You don't have to find out the exact result, just try to compare the result. You can find out the exact answer very easily. Now again a question from general organic chemistry. It is simple, that electromagnetic effect. Electromagnetic effect means in presence of an attacking reagent, how the electron density of the substrate shifts. If in presence of attacking reagent the pi bonded electron moves to that attacking reagent, then it is called positive electromagnetic effect. If in presence of the attacking reagent if in presence of attacking reagent, the pi bonded electron density escapes from it, it moves to the another direction, it is called minus E effect or negative electromagnetic effect. Now if you add H plus, it is positive. If you add to double bond, so if as H plus moves towards this double bonded system, the pi bonded electron will move towards that attacking reagent. As the pi bonded electron moves towards the attacking reagent, it is called a positive electromagnetic effect. No doubt, it is a positive electromagnetic effect. Next, which of the carbocation is more stable? Simple, isopropyl. If you write down the carbocations, it is isopropyl carbocation. It is isopropyl carbocation. So isopropyl carbocation, it is stabilized by plus I effect of methyl group, it is stabilized by hyperconjugative effect. Now triphenyl carbocation. So triphenyl carbocation, definitely it has extensive resonating stability. So here definitely triphenyl carbocation, it is definitely more stable than isopropyl carbocation. Ethyl carbocation. So ethyl carbocation, it has stability due to plus I effect of methyl group and hyperconjugative effect of methyl group. In propyl carbocation, it is CH3, CH2 followed by CH2 plus. So it will have stability due to plus I effect of ethyl group and 2 alpha H hyperconjugation. So no doubt here it will have resonance stabilization. No doubt it is a more stable carbocation. So here more stable carbocation, it is 2. So up to this we have discussed the questions which are framed in part A or section A as prescribed in NEET, prescribed by NTA in the upcoming NEET exam. So here we tried to frame most of the questions from that part which are not deleted in CBSE board, or and we expect that the questions may be of part B, it belongs to more of the deleted part. That is why we have framed in part A the questions from revised syllabus as prescribed by CBSE board. Okay, so in the next stage we'll discuss the questions related to part B, and part B we have 15 questions where we will get the 10 questions we have to answer, and 5 questions we have the extra. So total we have to answer a total of 45 questions. The total marks, maximum marks, it will be 180, but here in this year we will get 5 more questions to get more choice. It will bring a more choice to you.